Hello everyone, my name is Sarah LeBay and I'm currently a sophomore chemistry major at Mississippi State University. Today I will be going over with you what the functions and applications of aldehydes and ketones are. To start off, let's go back to the basics. What is organic chemistry? Organic chemistry is the study of the structure, properties, and reactions of organic compounds which contain carbon and covalent bonding. So, organic chemistry is carbon-based, right? And these compounds include not only hydrocarbons, but also compounds with any number of other elements, including hydrogen, nitrogen, oxygen, your halogens, phosphorus, silicon, and sulfur. So in organic chemistry, you have your functional groups. And your functional groups are specific compounds of atoms within molecules that have their own characteristic properties, regardless of the other atoms present in the molecule. So today I will be focusing on the two functional groups, aldehydes and ketones. Now they're very similar in structure, and I will be discussing the differences between the two. So let's start off with aldehydes. Aldehydes consist of a carbonyl group that has one hydrogen atom attached to it, together with either a second hydrogen group, which may be an alkyl group, or one containing a benzene ring. Some examples of aldehydes include methanol, which is formaldehyde, ethanol, acetonolide, propanol, which is a beta blocker, and 2-methylbutanol, and vanillin. So let's go over formaldehyde. Aldehydes undergo many different nucleophilic addition reactions, and this is because the positive carbon atom of an aldehyde molecule, which always has one bond attached to the small hydrogen atom, is susceptible to attack by a nucleophilic reagent. Water adds a nucleophile to a carbonyl group of an aldehyde to give compounds with two hydroxyl groups bonded to one carbon atom, and such compounds are often called gymdeals. Gymdeals are generally not stable enough to be isolated because they readily decompose back to the starting compound. An exception to this generalization is formaldehyde, which is almost completely in its hydrated form when dissolved in water. Now, formaldehyde is the simplest form of aldehydes, and it is made from the oxidation of methanol. Now, its common uses include preserving and embalming biological specimens. So you may see this a lot in your biology classes in high school whenever you're going to dissect some organism. Now, it is a gas, and so the most common format of exposure is through inhalation. Now, formaldehyde is the only aldehyde used to a significant degree in the industry worldwide. So, from its amount and its continuous exposure, it has been shown to cause cancer because it is a toxic gas. So, moving on. So, another aldehyde is vanillin. It is a more complex aldehyde. So you have other aldehydes of industrial significance that are mainly used as solvents, perfumes, and flavoring agents, or as intermediates in the manufacture of plastics, dyes, and pharmaceuticals. Well, there are certain aldehydes that occur naturally in flavoring agents, including benzaldehyde, which provides the odor and flavor of fresh almonds, cinnamaldehyde, the oil of cinnamon, and vanillin, the main flavoring agent in vanilla beans. So here you can see the structure of cinnamaldehyde and vanillin. Now, synthetic vanillin is used more often than natural vanilla extract in foods, beverages, and pharmaceuticals, just from the structure of it. So moving on to ketones. Ketones consist of a carbonyl group that has two hydrogen groups attached to it, and it can either contain benzene rings or alkyl groups. Now, the one thing that sets ketones and aldehydes apart is that there's no hydrogen atom attached to the carbonyl group. So, ketones are synthesized by a wide variety of methods because of their ease of preparation, relative stability, and high reactivity. They are nearly ideal chemical intermediates. And some examples of ketones include acetone, you have your paints and coatings, and methadone. So today I will be going over acetone. Well, acetone is the simplest and the most common ketone used. Acetone's chemical makeup includes elements that are both polar and nonpolar, which means acetone can be used with both organic and inorganic substances. Secondly, acetone is a good solvent because it's a miscible substance, meaning it can mix with water in all proportions. And acetone dissolves many organic compounds. Because of this, and its low boiling point, which makes it easy to remove by evaporation when no longer wanted, it's one of the most important industrial solvents, being used in products such as paints, varnishes, resins, coatings, and nail polish remover. Now, a more complex ketone would be ketone methadone. Now, ketone methadone is an opioid analgesic indicated for management of severe pain that is not responsive to alternate treatments. So it aids in the detoxification and maintenance treatment of opioid addiction. So if you're unaware what opioids are and their effects, opioids include heroin, opium, codeine, and morphine. They're a lot of pain medicine. They all create the feeling of happiness by attaching to that dopamine receptor in the brain. Now, these drugs change the brain's structure and function and how it works, resulting in an addition to these drugs, which leads to more harm to the brain. And this is because when opioids are prescribed therapeutically, when someone, say, has a surgery or they just need to be relieved of pain, but when that person starts using the opioids to activate these reward processes, when there isn't that pain there, then they can motivate the repeated use of the drug simply for pleasure, which leads to that addiction. And it not only leads to the wanting of the feeling of that pleasure, however, the increased compulsion for tolerance and dependence. And opioids are detrimental to the brain because the repeated exposure to the escalating dosages of the drugs cause the brain to function normally when the drugs are present and abnormally when they're not, which is why it's very hard for people to wean off of them. Well, the ketone methadone blocks that receptor, and so it then prevents the craving of the opioids. So the ketone methadone acts as almost a substitute for those opioids without causing the damage that opioids cause, which I find very interesting. Okay, so some additional uses of aldehydes and ketones. They're present in humans and other living organisms. So you have your carbohydrates, which include your sugars, starch, and cellulose, and these are based on compounds that possess aldehyde or ketone group along with hydroxyl group. So it could be either. Then you have your steroid hormones, which are your ketones, and these include progesterone, testosterone, cortisone, and aldosterone. And you have retinol, which is an aldehyde. So when combined with the protein opsin in the retina of the eye, it forms rhodopsin, which is the main compound involved in the process of vision. So you can see how your biological specimens, humans, living creatures, like these functional groups play a major role in both your carbohydrates, steroids, and different functions of the body. So as you can see on the screen, you have your testosterone, which is an example of your ketone, and you can see that you have your carbonyl group with no hydrogen atom attached directly. However, you can look at the retinol, which has a terminal carbonyl, which has terminal aldehyde with your hydrogen atom attached. So overall, as you've seen from this presentation, aldehydes and ketones are essential to both the industrial and living organism processes. So I would like to thank you all for watching, and I hope you learned a lot today. Have a great day.